Hello class, this is Mr. Lehman. After looking at your quizzes, there's still a problem out there with about a quarter of you, and it's calculating density using water displacement. So I want to go back over, hit this up, and so hopefully correct any misconceptions and get rid of any simple errors that the students are making. So remember, density is equal to mass over volume. Density tells us how tightly together material is packed. The more matter, the more mass something has per unit volume, the higher the density. And so a lot of objects, to find a volume, a lot of objects have a weird shape, the regular shape, so we use something called water displacement. So to find the volume of an object using water displacement, you need to have a graduated cylinder. And I apologize for my drawing here. Doing a freehand using my pad. Now with our graduated cylinder, you need to have some water in it, otherwise it won't work, because you want to measure how much the water level rises whenever you drop an object in completely. So it has to be completely covered with water. So we can't use just a few drops of water because that would defeat the purpose, because our object would not be covered in water. So let's say we're measuring the density of a rubber stopper. And so the first thing you have to do is to read the volume of how much water are you starting with. I don't have graduations here, so I'm going to make up a number. Looking at the very bottom of my meniscus, I'm going to say that we're starting with 12 milliliters of water. That's water. That doesn't have our object in it, therefore that has nothing to do with the final volume of our object. So this is just the water that we start with so that we can calculate the density. So we drop in an object that sinks. So we drop in a rubber stopper here. And when the rubber stopper sinks to the bottom, it's going to force water to go upwards. Now the more water that goes upwards, we know the bigger the object. The rubber stopper is not very big, so we read the meniscus again at the bottom. Let's say it went up to 16.3 milliliters. A lot of you are saying, oh wow, the final volume is 16.3, and plugging that number into the formula up here. But remember, 12 of that is water, so we're only worried about the rubber stopper. And so we need to subtract what we ended with, what we started with. And so 16.3 minus 12 gives us a volume of 4.3 milliliters for the stopper, and that's what we wanted. Up here, 16.3 is equal to the stopper plus the water. And we don't want the water, we just want the stopper. So we need to subtract the 12, which is only water, to get this a stopper. So we know our volume is 4.3 milliliters based on our measurements. The mass, we put it on the balance, and it tells us. That's pretty easy. So let's say, make it easy, that our mass was 15 grams. The volume was 4.3 milliliters. We simply plug it into this. We're dividing these two numbers. 15 divided by 4.3. And I don't have a calculator here, so let me open up my drawer to find one. And I was unprepared. I'll be right back. Sorry about that delay. 3.49. So our density is going to be 3.49. Our units will be grams per milliliter. And there you go. Congratulations.